Okay. You guys know a lot of vocabulary terms now. Well, hopefully at this point, right? Many of you know a lot of vocabulary words from Unit 1, and I think we proved yesterday, hey, I got to know those vocabulary words down cold to be able to do some of the stuff. But unfortunately, that's not enough to do a proof. Your knowledge is just not enough to do the proof. And that's not on you. Okay, that's not your fault. So what I got to show you through the rest of the week is some things that finish off the proofs, some connectors. All right, because proofs are puzzles. All right, I got to take my knowledge that I know of vocabulary and some of these connector properties that I'm going to show you today and tomorrow to finish a proof. It's a little bit like a puzzle. So I'm going to show you three today, three of them today. The first one, I always struggle every year trying to do this one. The first connector here that we're going to use in proofs is called the reflexive property. And if you read through the reflexive property, you're just going to be like, is this guy for real? A quantity is equal to itself. Thanks for the update, right, Mr. Carlino? Thanks for the update. Oh, segment AB is equal to itself. Segment AB, go figure. And angle B, oh, it's also equal to angle B. It's kind of like, I get it. All right. Trust me, though. Trust me. You're going to see where this comes into play at the end of the period. All right. So that's what that first one is saying. Reflexive property. And an angle or a segment equal to itself. All right. Just trust me. We are going to use it at the end. And also, as we do these, I'm going to start posting these up on the board over here because there's going to be a lot of them. So the first one up, reflexive. And all of these I put up here, I'll give you on next Monday's test. I'll have a sheet of paper with all these written out for you. Okay? Reflexive. We'll get back to that at the end of the period. Next up, and you guys are probably used to this. Let me ask you this. Back in your algebra days, what are you going to do with 4? If I asked you to find the value, what are you going to do with 4? What are you going to do with -2? And what are you going to do with 3? It's called substitution, right? That's what you did for algebra. You did something called substitution. Well, guess what? We can also do it for geometry, right? We could substitute in anything that's equal to each other, like you did for algebra in that last problem. So take a look at my first example here. I'll show you how we can do it in geometry using substitution. I don't need a diagram for this either. I'm telling you a segment AB is equal to another segment that's equal to 2 times AD. And then I'll tell you AD equals DB. Anybody see any repetition up there in the 2 givens I wrote? Anybody see anything that repeats? See anything that repeats up there in my givens? Is there anything that repeats itself in these 2 givens up here? AB equals twice AD and AD equals DB. Anybody see any repetition up there? Just tell me something that repeats itself up there. Where are we going there? Okay, let's try that again. Whew, Alex, anything repeat itself up here? Just there's something up here that is also down here. AD, right? Everyone, AD repeats itself. Everyone sees that. Alex, I'm still on you. AD is equal to what in this second one? DB. So anywhere I see an AD, what can I substitute in? DB. And write a new true statement. So all I'm doing is taking anywhere I see an AD, I can substitute in DB. Everyone see that? You did that with numbers last year. Now I'm doing it with segments. So now can you rewrite a true statement with DB substituted in? And what's that new statement going to look like with now DB substituted in? Shoot, where are we going for that one? Madison. AB, keep going. 2 times DB. There you go. So not only is AB equal to 2 times AD, it's also equal to 2 times DB because those 2 are equal to each other. So I was able to substitute it in. All right, now try one on your own now. I'll tell you angle A and angle B equal 90. A and C are equal, B and D are equal. Can you write 2? I just don't want 1. 2 new statements using substitution that are true. All right. I already know A and C are equal and B and D are equal. Can you write me two statements that are correct using substitution. So using the first statement, replace one of the angles and write a new statement, and then replace another angle. And we'll see what you got. Give me one of your statements. When you replaced it, give me one of your statements up here. All right, where are we going with that one? Halo, can you give me one of your statements?
Measure of angle C plus measure of angle B equals 90.
Great job. Awesome. Here's what Halo did. A is equal to C. So anywhere I see an A, I can substitute in C. Perfect. Love it. Everyone all right on that substitution? All right, give me another one now because B is equal to D. Anything else that you have for me? Anything else? Where are we going with 15? Hayden, got anything else?
Angle A plus angle B equals.
Perfect. Hey, B is equal to D, so anywhere I see a B, I'm allowed to substitute in angle D. Nice job. Did anybody have C plus D equals 90? You did a kind of a double substitution there. Fine. Fine. Is everyone all right how I can substitute now? And the key is, how do I know I can use substitution? What did I have in this one here? And what did I have here and here? Repetition. Right? I see things repeating themselves, so I know I can use substitution. 2 already in the books. Reflexive. And here comes the big one for the day. Before I introduce this one, I got a couple questions for you guys. Take a look up here. I got 4 line segments up here, A, B, C, and D. Those two are congruent to each other. So are those. Everyone with me? Okay. What would happen if I put A and C together and B and D together? What would you know about those two new line segments? If I put A and C together to form a longer line segment, and I also put B and D together to form a longer line segment, what are you going to know about? Are those new line segments the same length? Congruent? Yeah, everyone agrees, right? What if I put A and D together and B and C together? What would you know about those two new line segments? Also congruent. Does everyone agree with that? All right? Because the originals were congruent, if I put them together, what we're going to start calling addition, all right? Addition, if I put them together, the results are equal to each other. All right? And that is what this final property is, called addition. All right, called addition property. So let me just go through it. I did it with line segments a minute ago. If A is equal to B, C is equal to D, I can go A plus, what do you want to add to it this time? I can say A plus C is the same length as B plus D. Okay. Or let's write something else. What else could be true? I didn't have to add A to C. I could have added A to D, and that's the same as if I added B and C together. But here's the catch. If you want to use addition, and I'm going to keep asking this, and it's going to get annoying, you have to have two pairs of equal quantities to add together. All right? I must have two pairs of equal quantities to add together. You cannot use addition unless you have how many? 2 pairs of equal quantities to add together. If you only have one, if I take this away, that's not addition anymore. I need 2 pairs of equal quantities to add together. All right. right, you're ready. This is it right here. This is it. The moment right here. Your first proof. Huge moment in your mathematical careers. Huge. Deep breath. Soak this in right here. Huge moment right now in your mathematical careers. Your first proof of probably at least 100 all year long. All right, not trying to scare you, trying to be real. But this is your first of many, many proofs. First, before we even dive right into it, let's go over the makeup of it. Look familiar from yesterday. I'm going to give you true information. True information. And now I'm going to add in this. You need to prove to me that this is true. Okay? So I'm going to give you this is true. It's your job with your knowledge of vocabulary and reflexive substitution and addition I've shown you today. How can you show me that this is true? First step, just like we did yesterday. I gave you information. What did you do with that information right away? What did we do? Before we even went to statements, reasons. What did I have you do yesterday? Mark the diagram, didn't I? All right, so AB equals DE. What should I put on those two? Hash marks. Let's do it. Mark your diagram first. Hash marks. BC equals EF. What should I put on those instead? I don't want to put singles. Doubles, yep. So first step, mark your diagram. Now I got to start thinking on my own. How can I go from these pieces being equal to AC and DF, the whole thing's being equal? Okay, how do I go from there? And I don't want to make something new up. I want you guys to use something I've shown you. AB and DE are equal, BC and EF are equal. But I want the whole thing's equal. How do I get the whole thing's equal? What do I need to do? What do I need to do to what I've given you here? I need to do what to get to here? What do I do with these two pieces to get to AC? These two pieces to get to DF. What do I need to do to them? Put them together, right? AKA, what did I just show you? Put them together, what did we have? That's called addition. All right, so I want to use addition here, but you know what I'm going to say. How many pairs of equal quantities do you need before you write down addition? Two. How many did I give you? Two, so I can add. All right, does everyone see I'm going from two small pieces that I need to put together to get to the bigger ones? That's called addition, and you can only add unless you have two pairs of equal quantities, which I gave you. So the step two now, step two, and you're welcome, I already wrote in the givens. I shouldn't have. I should have had you guys write it in. Tell me what you're going to add together to get the whole things. So tell me two pieces right now you're going to add together to get to the whole. Two pieces I should add. For Juliana, what am I going to add? Two pieces only. Okay, let's start there. Perfect. AB plus BC. When I add those two pieces, it's the same, equal to. Tell me what other two pieces you're going to add together. That's the same as AB plus BC. 1, 4, where are we going? Jonathan, what other two pieces?
DE plus EF.
DE plus EF. Why is that true? Don't make something up. What have we been talking about? What's one of the properties? What's one of the three properties today I just used there? I just used what here? Addition. So that's what I'm going to write my reasons. Addition. Go back. Look at the proof statement. I wanted AC equal to DF. I haven't shown that yet. Your proof statement should be the last step in your proof. The last step should be the proof statement. They don't match here. They don't match. So I at least have one more step to go here. What's another name for AB plus BC? AB plus BC. What's another name for that? Isn't it AC? So all I'm going to do is, and you guys will try to figure out why, I'm going to put in AC there instead. It's the same thing, right? AB plus BC. It's another name is AC for it. Equals. What's another name for DE plus EF? DE plus EF. What's another name for that one? Ones, Jayla? DF. So all I'm doing is replacing it. This is the same thing as DF. All right, well, what gave me the right to do that? I don't want to make up something either here. I replaced it with something that's equal to it. I replaced it with something that's equal to it.
Substitution.
Well, what did I just do? I substituted in, didn't I? Something that's equal to it. Substitution. Is that what I was asked to prove true? Is this what I was asked to prove true? Congratulations, you've just done your first proof. Congratulations. There's your first proof. I'm going to give you information. You're going to use our properties and what you know from vocabulary to write in your own. Okay? You need to go from here to there. Okay? That's a proof. Okay? That is a proof. Questions? Oh, yeah. One definitely doesn't make you great. We got two more here. Go ahead. Look at those givens. Mark them on your diagram. Now we're talking angles. So do you want hash marks on your diagram? Nope. What do I want on my diagram instead? Arc marks. Yep. So go ahead. Put those arc marks. I'm going to walk around making sure you put those arc marks in the correct spots. Looks like you're going to need one set of arc marks and then double arc marks. So I'm going to walk around making sure you put them in the right spot first. Where's ADF? Okay, put an arc mark there. No. Why are we putting hash marks? Arc marks. Where's angle ADF? Okay, so I should have an arc mark there with CBE. Okay, so those two angles are equal. Now do doubles for those two. Okay, where's this angle ADF? Okay, put an arc mark there. No, you told me it was that, right? Look where you're tracing, Izzy. Look where you're tracing. There you go. With CBE. Okay, get rid of those because that's going to confuse you. Where's EDC? Okay, doubles because you don't want singles because they're not all congruent. And then ABF. Where's ABF? A to B to F. There you go. Got it marked. Okay, where's this angle? ADF. Oh, where'd you just trace your out? AD. No. You stop there. Look at the angle. Look at the angle ADF. A to D to F. There it is right there. That's the angle you're forming. Okay, so make an arc mark there. And congruent to CBE. So follow the C to B to E. What angle? See the angle you're making? You're ending there.
Oh, okay.
You're ending there. I don't want the arc mark there. I want the angle. There you go, right there. So erase those. And now EDC. Where's E to D to C? Okay, where's the angle you made there? Got double. Now go. Now finish it off with ABF. Okay, ADF is that angle here. Where's CBE? C to B. C, you got to follow the letters. C to B to E. Okay, what angle did you just form there? Where is it? Well, that's where you started. Watch. C, B, E. See the angle I'm forming? Where is it? Okay, put the arc mark there. So those two singles are equal. Now let's go EDC, which is what you mark there with the double. ABF. A to B to F. Double, yep. I'll get rid of everything else so it doesn't confuse you. Good. Okay, what are these names? Okay, we got work to do, right? Okay, I'm not too sure why these are there, right? Okay, let's go. ADF. Where's A to D to F? You're going backwards, F. You gotta follow the order of the letters. A to D to F. Okay, what angle are you tracing right now as you go from A to D to F? Where is that angle? Okay, put an arc mark there. CBE, C to B to E in that order. Where's the arc mark? Yep. Okay, let's go. EDC. No. We didn't say there. No, we just said right there. EDC. Double. So it doesn't look like it's congruent to the other. And then ABF. That's it. Don't put any of the lines. It's going to confuse it. Where do these come from? We got AD. Okay, that's fine. EDC. E to D to C. You didn't form that angle. We could just trace that. E, D, C. Where's that angle? Okay, that's where it goes. Okay. So put doubles there. And yep. Okay, there we go. We're good there. We're good there, Keaton. Yeah. Okay, where's this group? Put in their angles, making sure. Good. Okay, we're fine there. All right, I think everyone's got the angles in the correct spots. That was my first, making sure we could do that. All right, next up, let me put mine in. So those two were congruent. Those two were congruent. If you want right now, I saw some of you already. What's always our first statement? That's the same thing as yesterday. What's our first true statement? The givens, all right? Those always go in. Make sure they're in there. Angle ADF equals angle CBE. Angle EDC equals angle ABF. Why is it true? What's my reason? Why is that true? It's given. All the givens are true. All right, let's see what we got now. Now let's look at our givens to our proof statement. I need to prove ADC. Can you guys please find that angle, ADC? I'm asking in the proof statement. Angle, just locate it. I'm not marking it. I got to prove it's equal. Everyone see where angle ADC is. Please don't do this on yours. I'll just show you on mine. It's right there. There's angle ADC. I got to show it's equal to ABC. Can everyone find that angle on your diagram? A to B to C. It's right up here. Oh, what do I need to do to these two angles to get to ADC? I got to add them up. And what do I do to these two angles in the givens to get to ABC? I also have to. Oh, maybe. How many quantities do you need to add? How many quantities before I can add? 2. How many did I give you in the givens? 2. Okay, so we can add them right now. Does everyone see how I'm going from I got to add these 2 to get to the ones in the proof statement. And you can't write down the word addition until you have 2 pair to add together, which I gave you. So here we go. Step 2, similar to our last proof. Tell me the angles you want to add together. Give me a pair of angles you want to add together. Okay, here we go. Jesse, give me a pair of angles you want to add together. Angle.
Angle ADF.
Okay, I'm going to take ADF. And what angle are you going to add it to get one of the bigger ones? ADF and? Oh, use it. Right? You have ADF, which you gave me that one. So don't you want to add that one to it, right? Which we called EDC, right? So angle EDC. So I take those 2 angles, add them together. It's the same as adding what other 2 angles together? Here we go. Where are we going? Alex, what other 2 angles if I added them together? CBE plus ABF together. And what's my reason? What allows me to do that? That's a true statement because of what? That is a true statement because of, Alex? What's that? Okay, hi. I'm Mr. Carlino. Nice to meet you. What gives me the right to do this up here? What did we just do to the angles? That's all I'm asking. We added them. So I showed you a third type today called addition. That's it. Is that my proof statement? So I'm not done. You are not done until you write down the proof statement. So all I'm going to do, just like I did in the last proof, is I'm going to take ADF and EDC, add them and now call them what angle instead? Instead of just adding them, I can call them angle, Jonathan? ADC, and there you go. So now I can replace that with ADC, and I can replace the other statement with ABC. Replace, what did I just do with them? Substitution. And yeah, if you guys are picking this up, anytime this year you write down addition, the very next step will be substitution. Automatic every time this year in every proof. I write down addition, substitution. Questions? Yeah, it's going to be tough at first, yeah, until you start getting into the rhythm here, but you got to practice. All right, here you go. Example 3 to finish this off. Oh, yeah. All right, mark your diagram. Go ahead, mark your diagram. D, E, and BF. What are you putting on your diagram, everybody? Hash marks. I don't think I have to walk around to make sure the hash marks are in the right spots. D, E, and BF. Please do not mark your proof statement ever. All right, don't mark your diagram with your proof statement ever. That's what we're trying to show. If you want to go ahead, put in the given right there, go ahead. Might as well start there on the right foot. Ooh, all right. Here we go. A little bit different. Look at the proof statement. I need to somehow show why DF and BE are going to be equal. Okay, somehow I need to get to DF and BE being equal. All right, question for everybody. In the givens, I had DE, but in the proof, I need to go to DF. Let me ask somebody this question. How do I go from DE to DF? How do I go from line segment DE to line segment DF up here? Take a look. How do I go from DE to DF? How's that going to happen? All right, think about everything we've done today. How do I go from DE to DF? What's got to happen? In your own words here, what's got to happen? Mia, what's got to happen? Of what? What do I need to put onto it? If I'm going to go from DE to DF, what's got to be added onto it? Okay. I'm just going to jot that down off to the side. I got to add on EF. Everyone agree? Yes, I got to add on EF. Got it. Wait a second. Mia said addition. Why can I not add right now in step 2 like I did in the previous? How many quantities do I need to add? 2, but I only provided what this time? 1. So we cannot go to addition right away. Does everybody see that? You need two pairs of equal quantities to add, and I only have 1 in this case. So step 2 is not going to be addition like the last 2 proofs. Does everyone understand why before I move on? You need 2 things to add. I only got 1. All right, let's keep going. Mia did a nice job there. She said, hey, I need EF. How do I go from BF to BE now? Let's go to the other side there. How do I go from BF to BE now? What do I need for that to happen? 2, 6, where are we going for that? Jackson, what do I need to do from BF to get to BE? Add FE? The same thing? So you guys are telling me I got to add the same thing to both of these? Yeah? I'm not saying you guys are right. We got to add EF and EF to both. What do you know about EF and EF? They're what? They're the same, and they're equal to each other. Remember that thing I was like, oh, yeah, really? Reflexive, remember that? This is going to get you your second pair that we need to add. So this is going to be statement 2. Wait a second. I need to add the same thing to both of them. And what do I know again about EF and EF? What do I know about them? They're equal to each other. And what allows me to say they're equal? The reflexive. That's where it's going to come into play, the reflexive. It's going to get you the second pair you need to add. So if you do not have 2 pairs to add tonight, guess where you're going to get the second pair from? Reflexive. The same segment or angle you're going to add. Now, how many quantities do I have? 2. Can I add now? Okay. Tell me what you want to add together. Now that I have two pairs of equal quantities, you can now add in step 3 now. Just tell me what you're going to add together. Alex, back to you today. What do you want to add together? What segments do you want to add together to get to the proof statement, DF and BE? Let's start here. Give me two segments you got to add together to get to DF that we've discussed already.
DE
Plus?
plus BE.
BE?
Or BF.
Which one? DE, the one we marked congruent, and what else needs to be added to it?
EF.
EF, right? Guys, use what's in your statements already. All right, use what's in your statements. And that's the same as adding, go on the other side of the diagram. What other two segments should I be putting together here? Halo? BF, good job, plus EF. Why can I do that? Because of what property? Why can I just add them and set them equal together? Because of, Hayden? Addition. And we're still not good yet. That's still not matching my proof statement. So now replace both of them now. So let me ask somebody here quick. 18. Keating, what am I replacing DE plus EF with? DF. And what am I replacing BF plus EF with? BE. And again, what property says you can replace it just like that? Jonathan? Substitution. So it might not be, look, not all these proofs are addition substitution. How many pairs do you need before you add? Two. And if I only gave you one, probably where's that second pair going to come from? Reflexive. Okay, it's going to come from reflexive somewhere. Yeah, Mia, go ahead.
Because the second one, like BF and EF, they both had the F at the end, is that why you changed it to E?
Say that again.
Because with the EF and the EF, because the F is at the end, is that why did you change it to E?
Why did I change it to EF and not FE? Same thing. If you did same line segment.
No, like at the end, like
What did I?
it's BF plus EF. Why'd you change it to BE?
B right here?
No, at the end. Yeah.
Why did I? Okay, because if you take BF and EF up here, BF and EF, if I add those two together, I get another line segment, a bigger one called what? BE. So that's why. All I did was this is the exact same thing as that. So I replaced it because you always want your proof statement to be the last one. Okay, I don't want to leave step 3 as my last step because I haven't proved that yet. Okay, anybody else? Okay, so just so you guys can get off to the right foot here on the homework, 1 through 4, I just want you to use reflexive substitution or addition. What am I using? Okay, that's all it is there on number 1 through 4. What am I using? Now, when you start on number 5, notice it says write a formal proof. Starting with number 5, that's when you start doing statements, reasons, your givens first, everything there. Okay? Not all of them have addition. Not all of them have addition. They might be 2 steps. They might be 3. They might be 4. It's not always addition. Good? Call me over if you have definitely have some questions here. It's not going to be easy at first. You got to get in a routine. Yes. Yep.